Hi, today is December 31st, 2024. We will continue to talk about R programming. Today we will talk about R data types and vectors. There are 5 basic data types in R: numeric, integer, complex, logical, and character. So first, numeric. This is basically real numbers. For example, 10, 10.1, negative 88. So the numbers can be positive or negative, with or without digits. And the second type is integer. This is kind of special. We rarely see in practice. For example, the integer 10 is denoted by 10 capital L. This L declares that this is an integer. So you must add L at the end of the number to indicate that it is an integer. Otherwise, it will be assumed to be a numeric value. Complex. For example, 2 plus 7i. In this case, 2 is the real part, 7 is the imaginary part, and I is used to denote square root of negative 1. And logical, true or false. You can also use the abbreviation of them, T and F. Lastly, character. Obviously, you have to use quotes to wrap character values, either double quotes or single quotes. And it doesn't matter how long the value is. As long as you wrap them in a pair of quotes, it is assumed to be a character value. For example, we can assign the integer 10 to a variable x using this expression, 10 capital L. If we print x, we see this 10. It's similar to a numeric value. If we check the class of it, we see it's an integer. What if we just assign 10 to a variable? For example, y is equal to 10 without this L at the end. Then when we print y, we see 10. It's the same with what we got earlier. However, if we check the class of y, we get numeric. So see the difference between an integer and a general numeric value. Objects. So in R, an object is anything that can be assigned to a variable. It can be of different data types, and it can be of different shapes. There are 4 types of objects: single values, vector, matrix, and arrays. Basically, all of these are arrays. A vector is a one-dimensional array. A matrix is a two-dimensional array. And there are higher dimensional arrays, 3 or more, but we rarely use them. List is a special object, and then data frame. So in today's video, we will focus on vectors. There are 3 types of vectors based on the data type it contains: numeric vectors, character vectors, and logical vectors. Numeric vectors are also called data vectors. For example, we can assign a vector of numbers to a variable called weight. So apparently this weight vector contains the weights of 6 people. Notice that we use the function C. C stands for concatenate, joining items end to end. And R handles the entire data vector as a single object. For example, if we create a new vector, height, with also 6 values in it, and immediately we can calculate the BMI of these 6 people using this formula, weight divided by the square of height. We can just treat vectors as if they are just single objects. R will do the calculation element-wise. So for example, 60 divided by 1.75 square is equal to 19.59184, etc. Then logical vectors. So logical vectors contain logical values, true or false. We can also use the abbreviation of them, T and F. For example, we can create a logical vector L, which contains 4 logical values, T, F, T, T. And if we print it out, we see the 4 values. Sometimes a logical vector is a result from relational expressions or comparison expressions. For example, we got a BMI vector from the previous slide, right? 6 numbers. And if we compare BMI with 25, then we get a vector of logical values. Basically, this comparison is also element-wise. It will take each element in BMI and compare it with 25. So the length of the result depends on the length of the vector in the comparison expression. Character vectors. A character vector contains text strings, and each element is specified in quotes. For example, we create a short vector of student names, Abby, Becky, and Kathy, and then type it. And there are 2 built-in character vectors in R, lowercase letters and uppercase letters. If we type letters in R console, you will see the 26 lowercase letters will be printed out for you. Similarly, if we type capital letters, we see the 26 capital letters will be printed out for us. And there is a special type of vectors, vector type vectors. Sometimes categorical variables are coded as numeric variables. For example, we create a numeric variable called pain, which contains 5 values. These numbers 0, 1, 2, 3 are used to represent pain levels. And if we apply the summary function on the vector, the 5-number summary and the mean will be calculated for us. Because the vector is numeric when it was created. However, we know that these numbers represent levels instead of numbers themselves. Namely, the difference between 1 and 2 and the difference between 2 and 3 may not be the same. So the difference among levels may not be the same. In this case, it's better to convert this numeric vector into a vector type vector so that the variable can be treated as a categorical variable. In R, we can use a vector function to encode a vector as a vector. The syntax is very simple. We can just put the numeric vector in the function and then specify the levels. In this case, only 4 levels, 0, 1, 2, 3. Then we name it F pain, vector type pain, and then type it. So you see the first row is the same with the original pain vector, but there is a second row which shows you the levels of this vector. If we apply the summary function on this vector type vector, you see the frequency of each level is calculated. Instead of calculating the 5-number summary and mean, the frequencies are calculated. So this is a distribution table for this categorical variable, which makes more sense. Notice that although we have encoded the vector to a vector type vector, the levels are represented by integers still. To make them more interpretable, we can redefine the levels using character vectors. For example, we can just use the levels function. So this one can be used to redefine the levels of a vector type vector and then specify the character levels correspondingly. So none is corresponding to the previous level 0, and mild 1, medium 2, severe 3. And after this process, redefining the levels, when we type F pain, we'll see it looks like this. So all of the levels are represented by character strings now. Alternatively, we can label the levels using character strings when we convert the vector. So you see we get the same result. Next topic, missing values. In R, missing values are denoted by NA without quote. And NA is a valid value in R. For example, we can define a vector X with a missing value in it. Functions in R have special actions when they encounter missing values NA. Most likely, whenever they encounter a missing value, they will yield a missing value. For example, if we apply the min function on X, then we get a missing value. So missing values are contagious. Whenever there is one missing value in a vector, then the result will be a missing value. To avoid this situation and get a valid result, we can specify this argument na.rm equals true. So this argument will let the mean function ignore missing values and calculate the mean only use valid values in X. So you see we get a valid result too. So the mean of 3 and 1 is 2. There are some other functions dealing with missing values in R, na.omit, na.exclude, etc. You can just type $na.omit in R console to see more information about these functions. So there are some functions in R that provide information about vectors. The first group shows basic properties of vectors. For example, the length function will show the number of elements in a vector or a list. So by the way, a list is also one-dimensional. And the class function returns the class of an object. The class of an object determines what functions can be applied to an object. The mode function returns the mode of an object. The mode is corresponding to the basic data type of an object. For example, numeric, complex, integer, or character, or logical. And there are also some functions that we can use to check the basic data type of an object. Is.logical, is.numeric, etc. And then we have a function called is.null. This one determines whether an object is empty. Okay. So in R, null is used to represent the list with zero length and is often returned by expressions and functions whose value is undefined. And is.na function determines if an element is missing, na or not. So let's see some examples. X is a vector with 3 elements. The last one is a missing value. If we apply the is.null function on it, we will get a false value. That's because X is not empty. Though the last value is missing, X still has 3 elements. So we get a false value. But if we apply the is.na function on X, we will get 3 values, false, false, and true. That's because the first 2 values are valid values. They are not missing. And the last one is missing. So false, false, and true. So apparently, the length of the result of this is.na function depends on the length of the object we feed into it. And the second group of functions that provide information about vectors are aggregation functions. So they are math or statistics functions. For example, sum, mean, range, minimum, maximum, summary, table, etc. Okay. So table is used to summarize categorical variables. The sum, mean, minimum, maximum functions will only return a single value. And the range function will return 2 values, the minimum and the maximum. And the summary function will return the 5-number summary and the mean of a vector. For example, we define a vector x. X is a vector of values which contains consecutive numbers 1 to 100. And if we apply the summary function on it, we get a table like this. Okay, minimum, first quartile, median, third quartile, and maximum. And also the mean of the values. So aggregation functions are used to summarize a vector. The last group of functions can be used to change data types of an object. So as the numeric, as the integer, as the character, as the logical, etc. Then let's see some functions that we can use to create vectors in R. The first function is the C function. We have seen this quite a few times so far. C stands for concatenate. We can use it to join items together end by end. For example, we can create a numeric vector called num_v, and it contains 1, 2, and 3. We can also concatenate letters together, okay, A, B, and C. And C can also be used to concatenate vectors and single values. For example, x is 1, 3, 5, and y is 2, 4, and 6. We can use the C function to concatenate x, y, and 10 together, a single value 10 together. And the second function is the seq function. So this one is used to create equidistant series of numbers. The basic syntax is seq from equals, to equals, by equals 1. So the from and to arguments don't have default values. You have to specify them. And the last argument, by, has a default value, which is 1. This is the jump in the sequence. For example, if we want to create a sequence of consecutive numbers from 0 to 10, we can use seq 0, 10. If we want the jump to be 2, then we add an argument at the end. We add a by argument at the end, 2. Then we have a sequence of consecutive even numbers between 0 and 10. And we can also choose to add argument names in the function. If we do so, we can change the orders of the argument. We can say seq by equals 2, to equals 10, from equals 0. We can change the ordering of the arguments. If the step size is 1, we can use the shortcut syntax 0, 10. This is equivalent to seq 0, 10. And the series can also be in descending order. For example, 100, 90. We have this sequence of numbers from 100 to 90. The third function that we can use to create vectors is the rep function, the replicate function. This one can be used to generate repeated values. For example, if we want to generate a vector of ones, 10 of them, then we can say rep1, 10. Okay. And the first argument is the value or values we want to repeat. And the second argument specifies the time or times we want to repeat the value. And we can also repeat a vector of values. For example, V is a vector of A, B, and C. If we want to repeat V 3 times, we can use this code. Okay. Then you see the entire vector of V is repeated 3 times, A, B, C, A, B, C, and A, B, C. We can also repeat elements in a vector different numbers of times. For example, if we would let the second argument times to be 1, 3, so basically 1, 2, and 3, then we will repeat A once, and repeat the second argument B twice, and lastly repeat the third argument C 3 times, and we got this. So it's a very flexible function. And lastly, the replicate function is often used for grouping. For example, if it is known that the first 5 observations in the dataset are men and the last 10 are women, we can use the rep function to form a vector where 1 represents men and 2 represents women. So we can do this rep 1, 2 and C 5, 10. So this means we will repeat 1 5 times and 2 10 times. Lastly, data types in a vector. Theoretically, the elements of a vector must have the same data type. If you concatenate elements of different data type together, all the values will be converted to the least restrictive data type. For example, if we concatenate the logical value false and a numerical value 2 together, then if we print it out, you will see the false value is converted to 0 automatically. As I said before, in R, false is equivalent to 0 and true is equivalent to 1. So that's why false is converted to 0. Similarly, if we concatenate a numerical value 2 and the character value A together, then 2 is converted to a character value. So you see a pair of quotes is added to 2. From this example, it's very obvious that logical values are the most restrictive, while character values are the least restrictive. Alright, that's all for this video. Next time, we will talk about other data structures, matrices, data frames, and lists. Thanks for watching. See you next time.